Hey, we are beginning our study of exploring chemistry with exploring creation through chemistry. We're in module number 1 where we're talking mostly about measurements in units, and this is not particularly difficult math, but it may be a strange new animal to you, so you guys need to spend a whole lot of time paying attention to your lecturer and working these problems, because scientific notation and unit conversions and factor label methods, things that we're going to be talking about in this lecture and the next next 1 or 2 lectures, are just really foundational to algebra and chemistry. But first, they're going to ask you on your test, what is chemistry? So in your definition, you'll want to have a section in your notebook for definitions. Is that, okay, that's showing up. Chemistry is the study of matter. Okay, well that is a worthless definition for you to simply tell me that chemistry is the study of matter, because what is matter? Well, matter is
anything that takes up space or has mass.
Exactly. Anything, does that all fit in?
Barely.
Anything that takes up space or has mass. So you definitely want to be able to write out a definition of chemistry. Anything that takes up space or has mass. Space here has to do with volume. Mass has to do with what we have thought of as being weight. It's technically not weight, but for right now at the beginning, you can think of mass as just being weight. And, well, if chemistry talks about matter, which is something that takes up space or has mass, then you look around you and basically everything you see is matter. You know, your cell phone takes up space, your book takes up space, you take up space, pollution takes up space, you know, erasers take up space. But there is one thing that is very common that you see all around you that doesn't have, that is not mass. And the suggestion right here is air. Air must be the thing that, you know what, all of that noise shows up as distraction on the background of the video, on the background of the tape, Matt. But you think, well, air doesn't take up volume, doesn't take up space. And you've seen an experiment done where air really does take up volume, and you can see that picture because if you've got an empty balloon and then you go, you know, you have the big balloon and then it pops up. So air fits the first definition of matter, my dear, because it takes up space. When you put the air into the balloon, it takes up space. And the experiment that the others did on Friday in class, they had a yardstick that they balanced perfectly. You know, they had a string tied to a balloon on one end and a string tied to a balloon on the other end of that yardstick, and they balanced it perfectly on something. You know, if we did it at home, we would have balanced the yardstick on our shower curtain or something. But then they very carefully took off the one balloon, blew it up, you know, tied it back onto the string, and that yardstick wasn't in balance anymore. It tilted that way, so that demonstrated that air both takes up space and it has mass. So air is matter. But the one thing that scientists have determined that doesn't take up space is light. You know, you can't capture light in a bag. You can't weigh light. So if you saw like a lightning bolt, that lightning isn't going to have mass to it. The light from the lightning doesn't have mass to it. And when Rachel said, oh, it's got to be air, well, I had the same immediate reaction, that air would have been the thing. But that's not it. Light. So everything else that we see all around us, everything else is matter. So when we say that chemistry is a study of matter, which is anything that takes up space or has mass, what that means is that chemistry is pretty much a study of everything. So how are we going to be able to study chemistry if we have to study everything to do it. Well, all you guys have learned from having reports to do or talks to do that when you talk about everything, you can't begin to cover your topic. So what we're going to discover is that all matter behaves according to a few fundamental laws. So you need to know that all matter behaves according to a few fundamental laws. All matter behaves according to some basic laws. And it's as we become aware of what those laws are that we're going to be able to study chemistry. All matter behaves according to a few basic laws. But we're not going to talk about those.
Right in here, you can have your own show.
Is that too high? Okay. Is it about here where I need to write? Or here?
Yeah. Well, that's okay.
Yeah, I usually try and put a marker on. Thank you. But before we can actually study matter, we have to be able to measure it. And that's what this whole first module is going to be. It's going to be math. And it may seem like we're shooting you with a fire hose for this chemistry stuff too. But we've got to be able to get down all of this math and the measurements and the conversions and the vocabulary, because it's almost like this first module is the vocabulary for chemistry and for physics and for all of this science stuff. So, first we're going to talk about units. And I think the example that he uses in the book is very intuitive and very natural. Say you have a friend and he's going to make a picture frame for you. And you give him the measurements. You tell him it's a 50 by 60 picture frame that you need. And you want to have, you're going to make one, he's going to make one, and you're going to see who makes the coolest looking picture frame. And you want it to fit this very special picture that you got at a Royal Ranger ceremony or at a missionette ceremony or something. Like Johnny, whatever his name is. The guy that was the first FCF dude. Whatever, anyway. We have this picture, so the fateful day comes and here's your picture frame. And here's his picture frame. And yours is 50 by 60. And his is 50 by 60. How can that possibly be?
Different units of measurement.
It's different units of measure. And this isn't in scale, but this one right here, maybe this was measured in millimeters. If it were centimeters, it would be bigger. But centimeters is probably a better example of what it could have been measured in. This one could have been measured in 50 centimeters by 60 centimeters. And this one could have been inches, 50 inches by 60 inches. Because if you have, let's say that this is the equivalent of 1 centimeter to scale, it takes 2.5 centimeters to equal an inch. So here's your inch, so you have 1 centimeter, another centimeter, and 1/2 centimeter. So the scale is different. So what, all of you would know what I say, okay, go get me a piece of string that's 50 long. You wouldn't just go get me a piece of string, you'd say 50 wide, you would say 50 inches, feet. We wouldn't say meters or centimeters because that's not what we use in our regular system of measurements. But what this is saying is that measurement is meaningless without the units. So this right here, numbers mean nothing without the units. Highlight this. Numbers means is not what I mean to. Matthew, you should be writing all of these notes that I tell you to write. And these things go, kids, you guys will want to put all of these notes, if you're using legal paper or something that doesn't have holes, make sure that you punch holes in it so that you can keep them in your notebook. Numbers mean nothing without units? Nothing without units. So, answer has no units? You give me an answer that has no units, you give your teacher an answer that has no units. No units, answer is marked wrong. That's because the units of measurement are critical with so much of what we do with chemistry, because it's combining this or taking a portion of this, measuring this, finding the volume of something. So your units are important, 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 important. So we talked a little bit on Tuesday about the difference in the English system and the metric system, and how we're used to using the English system, but you have a foot, which was the length of some king's actual foot, and there's 12 inches in a foot, and there are 3 feet in a 3 feet in a yard, and 1,760 yards in a mile. But then there are 16 ounces in a pound, and 2,000 pounds in a ton. There's nothing consistent between the conversions in the English system. So metric system is the measuring system of science. And maybe some of you have studied it a lot, maybe some of you have studied it a little, maybe some of you have tried to study it not at all yet. But that's what this chapter is about. And someone told me a comment that was made that, this first chapter doesn't look to be too difficult. It's really pretty straightforward. Something that's really nice about the Apology of Science stuff is that it's written just as if, I don't know if you pronounce his name Weil or Wiley, but it's written just as if Dr. Wiley is talking to you and is lecturing. So it's a very readable book, but don't let it fool you for this first module here, because there's so much math in it that is important. So remember that I said that that mass is sort of like weight, but it really isn't. Well, weight and mass, this is the difference between them. What mass is that it is how much matter that is squished into an object. Okay, and you have to know these definitions too. The amount of matter squished into an object. I'm sure your teacher would give you credit of that. The amount of matter contained in the object. And what weight is it's a measure of how gravity acts on that mass. It says how hard a planet's gravity pulls on that mass. Weight is how hard a planet's gravity pulls on the mass. Probably a bunch of you have been to a science museum or a space museum, something where you say, okay, if I get on this scale here and I'm on Earth and I'm going to speak by faith, then I weigh 125 pounds. So I weigh 125 pounds on this scale for Earth. And then I go and jump on the scale for Mars and I weigh I weigh 98 pounds. And then I go and I jump on the scale for the Moon and I weigh, I think it's a sixth, maybe 30 pounds on the Moon. And then I go and I jump on, does Jupiter have mass?
No,
or is it
it's gas.
Okay, what's a planet that is not gas?
Uranium.
Uranus? Venus? Okay, Venus is a good one. I go to Venus and I get on the scales and I think, oh my goodness, I've got to go on a diet. I think I weigh 2,000 pounds here. And it's a huge difference on Venus. Have I changed? No, because I weigh the same, but what it is it's my mass has not changed. The amount of matter that's contained in me hasn't changed, but the gravitational pull of each of those 4 different planets has an effect on what my weight is. So that's the technical difference between weight and mass, and you guys need to know the difference between weight and mass. You need to be able to give a definition. And that means so that when we are doing measurements, weighing things in the study of science, we're not going to use the types of kitchen scales that we have that are ounces and pounds. We're going to use a mass scale, which has it in grams. Okay, you guys okay with these definitions? So the next thing is, let's see, okay, weight is dependent on your location, okay? Mass is independent of location. It doesn't matter where I was, if I was in Venus or Earth or Neptune or Jupiter, my mass stayed the same, but the weight changed. It varied depending on where my location was. So we want to talk now about what they call base units. And base units are the foundation of measurement for weight and for mass, for distance, for volume, for time. And this is a chart that whether you use my chart that I'm going to draw here, or you create your own, you're going to have to know the metric base units and the English base units for volume, for distance, and for time. But first, let's talk about weight, the units for weight and for mass. Remember that mass is independent of your location. Your mass is going to be the same on the moon as it is on Neptune, as it is on Mars, as it is on some star. And you have English units, which is what we use, and you have metric units. And the metric system is the language of the international science community. It's the language of science in general, and it's the measurement system of the world. So the measurement for weight, the metric system of weight, if I said, okay, how much does, let me pick up this, my child's very favorite class, pick up this book. How much would we say it weighs? We might say, oh, this weighs about a pound. So we don't automatically say this book right here probably weighs about 16 ounces. We would say 1 pound, half a pound, 20 pounds. So our base unit for weight in the English system is pound. In the metric system, if you have ever had any familiarity at all with the metric system, I don't think I want to go there yet. Okay, weight and metric system. Okay, this is something that we'll talk about later, and I'm going to have to study to keep ahead of you on this because it's been a while since I've worked with Newtons. And no, it's not a fig Newton or a strawberry Newton. It's just a Newton. The abbreviation is a little n. The abbreviation here is LB. Now the English unit of mass, I don't remember ever using it in high school or college. I'm sure I did. Or maybe I would have used it if I had tracked more in chemical sciences than in biological sciences, because that's what my background is, more biological sciences. But the mass is a slug. Yeah, I agree, it's strange. So here, let me draw this little snail slug here. Yet again, more illustration of why I'm not the art teacher. The English unit of mass is the slug. The metric unit of mass, now, this is someplace where this does show up a lot. A number of years ago, probably 30, 35 years ago, America tried to switch to the metric system. It obviously didn't work because we still do miles and pounds and things. But they would double label things, like we have bilingual labeling sometimes. But if you look on your candy bar, and I don't have one right now, but it'll say how many ounces or how many grams. So we say, when we're talking about weight, I would say that this book weighs probably about 450 grams, or maybe about 500 grams. And my cell phone might weigh about 50 pounds. That would be really bad, 50 grams. So you have milligrams, centigrams, you can have kilograms. Like if someone weighs 220 pounds, they weigh 100 kilograms. But the metric base unit of weight is gram, because...
Mass, you mean?
Thank you, Matthew. Please correct me when I make mistakes. By the way, those of you who are watching this video, today I have been saying wrong words all day long. The metric system of mass is gram. The English system of weight is pounds. And these are the two units that we're going to have to be converting between the most. In this class, we're not going to talk a whole lot about slugs, we're not going to talk a whole lot about newtons. You might have to do a conversion or two, but it's mostly pounds and grams. Okay? So do you guys have that chart done to where you can read it and be able to study it? It's interesting, when my husband studies, he'll take this piece of paper that's about this big, and he writes, so that I need to get out my microscope to read it. And then, see my page of notes right here. Here, camera, see my page of notes. This is really crammed for me. And my husband would probably cram all of this stuff on like a third of my phone. And I'm watching how the kids in this class are studying, and one of them writes notes like my husband, and another one of them writes notes like I do. So we have this. The next thing that we want to talk about, see, I get to drink coffee again. Oh, yeah, that's gross. There's junk on the bottom.
Ew.
Stuck from my coffee holder. I told you that you were going to have to know the units of measure for distance, volume, and time. So that's what we've got here. So draw yourself this nice chart, and then you won't have to create your own chart, but you can if you want to, if you don't like the way I do mine. Of course, make your chart look neater than mine. So we're going to divide it into 3 areas. We're going to have the one on the left be a little bit larger. Well, be a lot larger than the ones on the right. Then we're going to split it in thirds, because we're going to be talking about distance, volume, and time. So first we're going to have units of distance, units of volume, and then we're going to talk about time. And distance refers to how big something is. Volume refers to how much space something takes up. And time refers to how long. And once again, we're going to have our metric system, and we're going to have our English system. So let's just think. When we talk about distance in the metric system, this shows up, it does show up in track and field and swimming. It doesn't show up in football, but it can show up in track, particularly in swimming. How do they refer to distance? How far, like I've got
Meters.
Meters. Meters are the metric base unit of distance, and a meter is abbreviated with a small m. And the base unit in the English system, even though a meter and a yard is about the same, The base unit in English is feet, which is abbreviated little f, little t, period. In English, this is another thing that we have transitioned over to in America, particularly when we're talking about drinks. Now, not my coffee here. My coffee here, I think, is probably 24 ounces. But what do you most often buy if you go to the grocery store and you're buying a soft drink?
Liters.
Yeah, you get a 2-liter bottle. So the base unit of volume is the liter, which is a capital L, is how they abbreviate that. Now, a liter and a quart are about the same size, but quart is not the base unit in English. Gallon is the base unit. And that's abbreviated small GAL, period. And then, when we're measuring time, we finally get something that's easy. It's seconds. Now, there's no difference in the measurement of time in the metric system and the English system. And if you will take the time as you're going through and doing your exercises, doing your work, write this chart out a couple of times, or maybe it doesn't work for you to have it in pictures. Maybe you just want to say something like, let's see if this will still show up. Distance, meter, feet. Actually, let's do distance with a colon. Volume is liter and gallon. And time is second for both of them. Do something that engages your ears and your eyes and your hands so that you have got totally cemented down what your metric base units are and what your English base units are, because you definitely, after you have covered this lecture, whether it's on Monday or Tuesday, but after we've done this, you don't ever want to have to go back and say, I don't know what the basic base unit in the metric system is per volume. You have to have that in your head. Okay. So I'm going to go ahead and keep this lecture going. Something that is a really essential, let me see, can I move over this way to write some more notes? Because I've got people who are still writing this chart. Yeah. A key.
Ronnie, you can go.
I can go?
Yeah.
Okay. Something that's really key to the study of chemistry is that matter has the ability to change. So in your notes somewhere, matter can change. And if you watch ability to change, if you ever watched The Shaggy Dog, either maybe you watched the very old movie, The Shaggy Dog, or any of the various revisions of The Shaggy Dog. It's been so many years since I watched it, I don't remember, but I think there was this ring, and it lets you transmogrify, and I think Calvin uses the word transmogrify too. But the dog changed into the professor, or the professor changed, something else.
Professor into the dog.
Okay, I'm professor into the dog. The matter, which was the professor, changed into the dog. Now, of course, that's not a legitimate change, but it's an example of matter having the ability to change. And when it changes from one thing to another, that's when we talk about states of matter. And a really good example of that is with water. Water is a chemical combination that consists of 2 atoms of hydrogen and 1 atom of oxygen. But it can exist in 3 states. It can be a solid.
Liquid, gas.
Exactly. It can be a liquid, or it can be a gas. And when it's a solid, what is it?
Ice.
Water.
It's ice. when it's a liquid, you know, it's a drink, I'll put drink here. And when it's a gas,
It's in
you know, it's water vapor. Steam, I'll put down steam, and that's probably not the technically correct term. But this is one chemical compound. You know, it's matter because it takes up space, it has volume. It's one chemical compound that can exist in 3 different states. It can be a solid, it can be a liquid, or it can be a gas. And it can exist sort of in those states almost simultaneously. Like, think about if you had a big block of ice and you put it in a pan on the stove and you turn it on and it starts to melt. You know, so maybe you've got some water in there, you've still got some ice in there. Maybe you're seeing some steam coming up off of it at the same time. So what I pulled out of the book says the shape, the size, the chemical properties of some substances change over time. So the shape and the size of this changes over time. Now, back to this idea of base units. We talked about base units in English and how the conversion between them is confusing because there's no consistency. But in the metric system, you have the conversion between different units in the metric system is all based on multiplying or dividing by a power of 10, either by 10 or 100 or 1,000, 10,000s. So that is what's really, really good about the metric system. So you remember what our base units are. So we have our base units, and there are 3 of those. For volume, you have liter. For mass, you have gram. For time, you have second, but we're really not going to talk about time. But these are the base units. And then they also have what they call prefix units. And when I was studying the metric system a long time ago, I don't remember being taught the idea of it being prefix units, but I also don't remember being taught how to eat, you know, or how to walk. You know, it just happened. So maybe I was taught using this idea of prefix units, but it should make it a lot easier for you guys to become proficient in the metric system. So let me write, and once again I have a chart that I've gone into this book and I've combined systems. So you guys go ahead and copy this. And Mr. Weibel, I'd like you to copy this out on a separate piece of paper on a big page, please. This is prefixes in the metric system. Can you see that? Does that show up in metric system?
Just barely.
Okay. So first, we have our, right here, this is going to be the base, units in the middle, and I'm going to work out from it. Right here in the middle. I guess 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to have 9 columns, 9 rows all together. So if you want to make yourself, you know, use 9 rows on your paper. Or use 18 rows so that you have plenty of space, plenty of white space so that you can keep up with what you have. And this is going to be our base unit. So this is 1. And on this side, it's smaller than 1. And down here, it's going to be larger than 1. I bet this doesn't even show up.
barely.
Just barely.
Smaller than 1,
That's the
larger than
farthest
1.
you can go out.
Okay, so we have micro. This is the prefix, micro. And micro uses the Greek letter mu. It's sort of like that. That's the symbol for micro. And it would be micrometer. What you do with the prefixes is you use the prefix and the base unit. Micrometer, microliter, microgram. So we have meter, liter, and gram. It'll take just a little while to set this up, since I'm asking God to show me how to do it. Base unit. The base unit of volume is liter. The base unit of mass is gram. And what's the other one? Liter, meter, and second, I guess, liter and gram. Liter, gram, and meter. Okay. Liter is volume, gram is mass, meter is distance. So what you do with a prefix, or the prefix is this Latin thing that comes in front of the word. And that's where Latin roots come in. But you attach the prefix, pre means before, so you put that before these base units. So you're going to have a microliter, microgram, micrometer, except they don't call it a micrometer anymore, they call it a micron. And I checked with my husband to make sure because I thought it was a micron. And he says yes, they don't use micrometer or micrometer.
Isn't that 0.000001?
Yes, there's
days.
6 zeros.
6 zeros, I thought it was 5.
Well, there's 6 places after it. So a micron is 10 to the minus 6. I'm going to put that over here on the left. 10 to the minus 6. It's 0.00000, 1, 2, 3, 4, 5, 1. And frequently you'll have a 0 in front of the point. So a micron is, let's look at the place names here, 10th, 100th, 1000th, 10,000, 100,000, millionth. A micrometer, micrometer, micron is the preferred term. A micron is 1/1,000,000th of a meter. So if a meter stick is about 39 inches long, a micron, it takes 1,000,000 of those lined up in a row.
A
To be a
micron
go-
is a what?
It's 1/1,000,000th,
Of a meter.
0.0000001 of a meter. So that's what a micron is. And then you have a millimeter. And a millimeter is also a little m. I mean, a milli is a small m. And a milli is 1,000. 0, 0, 1. Tenths, hundredths, thousandths, which is also 10 to the minus 3. Then you have a centi. Centi is a small c, and that's 100th, not a millionth or 1,000th. It is 100th, which is 10 to the second, 10 to the minus 2.
Million is 1,000th.
A milli is 1,000th. And a deci, or deci if you want to say it by itself, that's a small d, and that's a tenth, 0.1, which is 10 to the minus 1. And these negative exponents over here, this is what we're going to be using with the metric system. And then all of this is, this is all smaller than 1. Whatever your base unit is, smaller than 1. Like a microliter, this micron right here is, instead of being a micrometer, it's a micron, but you still have a microgram, a microliter. So it takes 1,000,000th microliters to make 1.
1 million, you mean? You said 1 million.
It takes, A micron is 1 millionth
But it takes a million.
of a liter. So 1 micron is one tiny little 1 millionth part. So if you put 1 million of those microns together, of those microliters together, you end up with 1 liter. You think of millennium, you know, we went to a new millennium in all of our lifetimes. Millennium is 1,000 years. That's from the Latin milli. So milli means 1,000th, tenths, hundredth, thousands. So a milligram then would be one, you know, it's smaller than one. It is one teeny tiny little bit. It is 1,000th of a gram, or 1,000th of a meter. And I'm sure that all of you now have measured things in millimeters at some point, even if you've only just measured it once or twice. It takes 1,000 of those little millimeters to make 1 meter thick. Then you have centi. You guys all know that century, you know, that's 100. Centi is 100th. A centigram is 100th of a gram. 100 centigrams equals a gram. Deci, this one right here, you have to know what it is, but this one right here, they don't use a whole lot. They're not going to use centigram a whole lot. They're not going to use microgram a
You
whole
meant
lot.
decigram.
What did I say?
Cento.
They're not going to use deci a lot. You're going to all constantly see milligrams. You're constantly going to see centimeters, things like that. And then for those values that are greater than 1 base unit, and when we finish filling out this chart, I'm going to stop this video, and then we're going to do more unit conversions later. Chemistry, guys, I'm sorry, or I'm glad that we can do this, because chemistry is a big class. You know, even in our co-op, we have chemistry for an hour and a half. There is no way, no how that you can competently, that you can comfortably go through chemistry unless your parents are real comfortable helping with you. Unless you know some chemistry or know the math. Okay, and I bet you, Matthew says we've been doing this for a long time, so I may be running out of space on the memory card. Let me quickly go through this. We have deca, D-E-C-A, hecta, kilo, and mega. These are, and so you have a deciliter, hectogram, kilometer, a megaliter, where guys who are really into studying wars or girls, they'll hear about megaton bombs. A megaton, 1 megaton nuclear device has the destructive power of 1,000,000 tons of TNT, 1,000,000 tons of dynamite. So deca is, if deci is 1/10, what do you think deca is going to be? 10. Hecta is 100. Kilo is 1,000. Mega is 1,000,000 times.
You wrote 100 twice.
Thank you. And 10 is 10 to the first, 100 is 10 to the second, 1,000 is 10 to the third, 1,000,000 is 10 to the sixth. One of the activities in the Olympics is the decathlon. A decathlon is comprised of 10 track and field events. 10, so we have a deciliter would be 10 liters, decameter, 10 meters. This one right here doesn't get used a lot. Doesn't get used so much in our thing. A hectoliter, hectogram, hectometer is 100 times. That one doesn't get used a lot. They used to measure, and I'm sure they do in parts of the world now, they would talk about hectares, which I think is a unit of land measurement, but you really don't see that a lot. Kilo, of course, that gets used all the time. Kilogram, kilometer, kilometer is 1,000 meters. Mega, we really don't use that a lot within our science classes that we're doing at this level, but a mega is 1,000,000 times. So kilo, centi, milli, it's going to be the ones that you use most commonly in this class for doing prefixes in the metric system, but for this first test that you guys are going to take, you need to make sure that you are able to get all of these. But the ones that you have to know inside out, milli, deci, kilo. Okay, that's the end of lecture 1.